increase, this is referred to more stability of the body. So I bring this figure to understand what is meter center, what is the case of the stability of the body, to can able solve the question here. So you can now check answer.
C.
Body B is more stable than body C because the meter center, it is both is positive, so both is stable, but higher distance, so it's more stable.
Yeah.
Body floating in a liquid is said to be not in equilibrium. Not if the meter center lies below the center of gravity.
True. A.
Yes. Take a breathing like this and ready for this part. Okay. Types of fluid flow. Actually, you classify the fluid in different categories. Not all related together. It should be defined, go to define any fluid, defined for separate part. Like I can say, this flow is laminar and unsteady and uniform and is rotational and compressible and 2D and viscous. It should be select one from each one. Not mean this fluid is steady, it's by default is turbulent, is by default is non-uniform, and so no, it's not like this. Each one have a parameter to can measure for this. Let's see by easy way. I give you all information for and just to go for the slide one by one for check. But I will give you now a summary for that. First, 1, 2, 3 dimensional. It is very easy. It means if the flow moving in one direction, like pipeline, one dimension. If, for example, moving in open channel and moving in X direction and they change it also for up and down for the height, so 2 dimension. 3 dimension is like the flow is moving in the 3 dimension, like flow around the car and such like this. Compressible and incompressible. This is actually related for the relation between B and V, volume and the pressure. So if the pressure apply a change, so it's created change in volume on the same time. So this is compressible, which is normally gases time. But if we apply for the pressure change, there is no change for the volume. This is set incompressible. So pressure change create volume change. This is compressible, but no change in volume. This is incompressible like lipids. Let's see other laminar and turbulent. Laminar, from the name for laminar, it is laminar, smooth. The layer is moving together as a smoothing way. The layer is moving together as a smoothing way. So the layer is like moving one set. It's mean is a straight line? No, not like this. Not means a straight line. Straight line, for example, we can set for one dimension. But this one, it means straight line? No. We can moving, the fluid can move zigzag. But still, is one set, coherent layers together. Turbulent, no, it's not moving fluid like easy or smooth layers. Just we have a turbulence, we have eddies, we have a circulations for the flow. For viscous and inviscid, not mentioned here, but will be see also. Viscous, it means you see the viscosity effect for the flow. Viscosity effect of the flow for what? Velocity gradient. So if the flow is viscous flow, it means the viscosity is affect for the dynamic motion of the flow. But if it is inviscid flow, normally this one, it will be like flat profile. Flat profile, it not have a profile, like parabola profile, like linear profile. It's like flat profile. Rotational and rotational. This if the flow, just I check the inside particles. If the particles during the moving of the flow is rotated along one axis, this rotational flow. If not rotated along one axis, this is rotational flow. I will show you one video for this one, quick one video for the rotation to be understand. So what's remaining now here? Steady, unsteady, and uniform and non-uniform.
So can you please explain turbulence and rotational flow together?
The flow, it means if turbulence, it is rotational.
Yeah, turbulence, I think.
Not
Okay.
not like this. No, not
Okay.
like this. One minute, please. 1 minute, please. Steady, unsteady, and uniform, ununiform. As we know, the velocity, please focus with me for this point, especially because many confusion for this point, for many engineers. Velocity, actually, it is a function for two parameters, x and t, partial x, partial t. So each one is go to study behavior for the flow. This is study behavior for the velocity with time. But this is study behavior of the velocity with x. So please, and two not happen together. It means what? If you study time, so it should be fix the position you study. If you study position, so it should be an instant time. It means not constant time. No, at the same time. No, all happen at the same time. The time factor not measured. Okay, to be easy. For example, this tube. Okay, if you measure study x, uniform, non-uniform, so I study at the same time in instant, x here, x here, x here, different x. What is the velocity profile for each one? What is the velocity here? What is the velocity here? What is the velocity there? Clear? If the velocity profile for all the same, so this one is uniform. But check with me for this expander like this. I check here, there, and so on. So still an instant, the time factor not affect. So you study what? Also position x1, x2, x3, like this one. But the velocity profile here, it's not like this, not like here, not like there. This for sure. The velocity profile change. So this one non-uniform. But for the time, whatever the shape is like this or like this, and also because many engineers consider if uniform, this is steady. No, not related for that. Maybe steady with uniform, steady with non-uniform, maybe unsteady with uniform, unsteady with non-uniform. Okay, all can happen. For time, for example, a tube like this, it's okay. It's measured for all the x1, x2, x3. No, we can't do that. If you measure time, fix the position. It means I measure here at x1, for example. What you measure at time t1, what is the velocity profile? At time t2, what is the velocity profile? At time t3, what is the velocity profile? So I measure with different time, what is the velocity profile? If not a change, this is steady. The same case like this linear, like this pipe. I measure at x1. but T1 not the same T2, not the same T3. So this one unsteady. So both is uniform, but steady and unsteady. The same we can do for non-uniform. I just take at x2 and measure at different times. If all the same velocity profile at different times, so this is steady. Not the same, so unsteady. So we can non-uniform with steady, non-uniform with unsteady. Normally for the equations, we can expect or we can get the results from the meaning of the equation or the figure, if sometimes a lot give you figure, and request from the figure to just to check this uniform, non-uniform, or steady, unsteady. From the figure itself, we can expect this uniform and non-uniform, but steady and unsteady, normally we can't get it from the figure. So how to get it? It should be mentioned for the problem itself. Is this constant rate, not constant rate, and so on. Except some cases. I will show you one case is important. This we can, from the case itself, we can expect this is steady or unsteady. Okay, let's see what we discussed now. Steady and unsteady is only measure here the velocity, check the velocity with time at constant position. Uniform and non-uniform, it is measures at different position at certain time. Here this is the case for unsteady by default from the figure you can expect, but uniform and non-uniform, it depends for the profile of the tube. What is this case? Let's study together and give you what is the reason for that. This is tube. As you see, this is the flow coming here. If you check at different position, uniform, but this one non-uniform. But steady or unsteady, you can get it from the figure. This is one of the special cases you can get it from the figure. Why? Here we have Qn and we have Q out, correct? Yes. If the Qn not equal Q out, so what you expect from the height here? Height vary, correct? Yes. We know later to can get the velocity equation here, the velocity equation, how to calculate the velocity equation. This can get it by applied by Bernoulli equation. So by the way, at the end, it will be get the velocity is a function for h, 2gh. Which is mean what? H is varying. So it by makes sense, the velocity what happened? Vary. So at the same position here, this is here, at the same position, velocity what? Vary. So it means this by default is unsteady flow. Unsteady flow, but uniform or non-uniform, it depends for the exit shape. This is clear for you?
Clear, sir. Hello, clear.
A flow through an expanding tube at constant rate is called
Unsteady non-uniform flows.
steady non-uniform. Expanding tube non-uniform and constant rate is stable. Laminar and turbulence is what we talk about for smooth layer, and turbulence we have liquid and circulation. Viscous and inviscid, also what we discuss. Viscous is flow, is viscosity creates stress, which is effect for dynamic motion. Same like this, we have a velocity gradient here, big velocity gradient. But the inviscid flow, the force due to viscous shear is small, which is not effective for the dynamic motion. It's only almost it is flat profile. Compressible and incompressible, as we said also, the change of pressure, change of the volume. So this compressible, which is gases type, and here there is no change for the volume, which is compressible like liquid type. The volumetric change of fluid caused by a resistant is known as
B.
Compressibility, C.
compressibility, exactly. Rotational and rotational, this is also what we said. The first one here, the flow is moving. Whatever is the bulk flow is rotated. We don't care about that. We check the particle itself. If the particle not rotated along one axis, so it's like this, particle is the same, so this is rotational. But this the particle is rotated along one axis, this is rotational. I will show you one video as I did. 1 liter of water occupies a volume of 1,000 centimeter cube. One-dimensional flow, the flow is
B.
yes, exactly, one straight line. Flow is said to be ideal if it is
Compressible. A.
only incompressible.
Inconversible, in viscous also, sir.
Yes, in viscous and
Inviscous,
incompressible. One from exam questions. A fluid with a specific gravity. You know now what specific gravity, correct?
Yes.
And the
Yes.
kinematic viscosity 1.5 centistoks. Kinematic viscosity, which is nu. So nu is equal. This is not clear.
Under root 2 GH.
Nu is equal 1.5 centistok. As I tell you, we have another unit stock, which is centistok. And they give you the conversion for this one centistok is equal blah 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 feet square per second. So if this multiplied by 1.0764 to the power -5, it will get it feet square per second. Flow through 4-inch diameter, so diameter is well 4-inch, and velocity is equal 5 feet per second. This question actually, if you check the sharing material on internet, for not for us, for the common material shared on internet, the answer shared is not correct. Okay, you can go back for the material and you check, you found the answer is not correct. Why? I tell you. Reduced number actually is equal VD over nu. I know some engineers say the other equation, reduced number is equal rho VD over mu. So what is this? Actually, if you take mu with density, viscosity, this one, mu over rho, this means what? Nu. So we can write it like this, VD over nu. Okay, which is matched with the given here. So let's substitute. V is what? V is 5 feet per second, standard, no problem. Diameter is 4, so this beaker for feet per second, this is inch. Other one, 1.5, centistok, I multiply, as I told you, 1.0764, multiply 10 to the power -5 feet square per second. Okay. If you continue solving for this one, you get the answer as the material shared on internet, which is wrong. Why? Because actually, this is 4-inch. Inch is not matched with feet. So this is the tricks for the problem, for British problem for the exam. They play a lot with you with this way. They give you some British unit, it's not matched with together, other units. So this inch, this feet, so it should be convert. I divided here by 12. This by 12, so to be now is feet. Now we can continue solving. Okay. Other advice for solving this problem. My advice for this, I see all answer 10 to the power 6, 5, 6, and 4. So it's better to not include this one in the calculator. This is my advice actually. And put it here outside, 10 to the power 5, because this down, I put it up. And finish all calculation and put the answer here. If you found the answer related for 10 to the power 5 direct, you can select direct. If you need to shift the decimal to be 4 to be 6, but all in all, it's better than to write it this in the calculator. Maybe go mistake for the power or something like this. This is my advice, please. So if you go for calculation, we're going to calculate together for this one. Let's go 5 multiply 4 divided 12 by 1 divided 5 divided 1.0764. 1.032. 1.032. Which answer is needed for this? Need to change this decimal or something, or can get it direct? Anyone get answer? C.
C.
Yes, 1. Normally
Yeah.
also another thing. Normally it's a problem coming for the exam. It's not exact answer you can find. All is most nearly. The answer of the material shared on internet, this is wrong. Is wrong. Why select this one? If you use 4 without divided by 12, you get this answer direct. Okay, you can check this. Try it on the at home and you can check it by yourself. Okay.
Thank you.